All right, this is a review of shell model and Lewis model or Lewis structure. I'm going to do a few of these for you, and then you're going to answer the rest of them on your own. Okay, so here we have a chart. We're supposed to give we have the element name right here. We're supposed to give the shell model and the Lewis structure. Okay, so for beryllium, I know that the rules say that I need to have the number of shells an element has equals the number of rows on the periodic table the element is on. So beryllium is on the second row, so the shell model will have 2 shells. Okay, and then it says that the maximum number of electrons in each shell equals the number of boxes in each row. Well, beryllium has the 2 electrons on the first in the first shell. Remember, those 2 electrons are the hydrogen electron and the helium electron, and then it has the lithium and the beryllium electron on the second shell. That would be the shell model. And the Lewis structure is way easier. Remember, it's just the symbol and then the 2 dots that represent the valence electrons, which are different than the total amount of electrons. Okay. Neon, I'll let you do that one. Hydrogen, I'll do this one. This one's easy. Okay, so H, and it's the first element. So there's just one shell and there's 1 dot. Lewis dot structure looks like this. So easy. Oh my gosh. And then you can go ahead and do aluminum. All right. We're going to complete the table below. And the table tells us that we need to know the number of protons, the total number of electrons, and the number of valence electrons. Remember, these are different things. And the number of shells, and finally the Lewis structure. So chlorine, let's analyze chlorine first. Chlorine is right here. It's number 17. That means we know there's 17 protons. The total number of electrons in the neutral atom of chlorine has got to equal the number of protons because it's a neutral charge. That's 17 total. How many valence electrons there are? Well, chlorine is in the third row of the periodic table, and you count from left to right. 1, 2, skip the middle, 3, 4, 5, 6, 7. So there's 7 valence electrons for chlorine. Number of shells, we said, is in the third row. So that means there's 3 shells. And then the Lewis dot structure is you put the symbol, and then you draw the number of valence electrons around. So 1, 2, 3, 4, 5, 6, 7, and that's it. Okay, we're still, yeah, okay. Let's do potassium. Potassium, find potassium on the periodic table. You're finding it, you're finding it, you're finding it, and you found it. There it is. K for potassium. The number of protons for K is 19 because it's number 19 on the periodic table. The total number of electrons, since it's a neutral atom of potassium, has 19. The total number of valence electrons, remember, is the amount of valence electrons in the outermost shell. And since potassium has 1, 2, 3, 4 shells, the outermost shell is the fourth one. And then we're supposed to count the number of boxes in each row. So that would just be 1. So potassium just has 1 valence electron. Number of shells, we just said a moment earlier, was 4. How do we know? We just count from the top. 1, 2, 3, 4. Potassium's on the fourth row. And then the Lewis dot structure should simply look like this. A K with how many dots? Not 19, just 1. 1. Try francium on your own. Francium, number 87, just letting you know. Okay, so all of these are more practice of doing the same thing, where we're finding the number of protons, total number of electrons, number of valence electrons, number of shells, and finally the Lewis structure. You can practice these on your own. All right here, there's nothing special about them except for when we get down to here. Okay, so this is where it's different. Okay, so potassium, let's do potassium ion this time. Potassium ion is different than potassium atom. Okay, so potassium, we know, has 19, there we go. Potassium we know has 19 protons, and the total number of electrons that potassium ion has, well, remember, potassium ion lost that 19th electron so that it could have 18 electrons, like the closest noble gas. So potassium ion actually has 18 electrons. The number of valence electrons that potassium ion has, this is the tricky part. Potassium doesn't have one valence electron anymore. Remember, it lost that 19th electron. Now it has 18 electrons like argon, but argon only has 8 valence electrons. Those valence electrons are the electrons on the outermost shell, and that means the electrons from left to right on the highest row. So that's 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 valence electrons. The number of shells that potassium ion has, it's no longer 4. It's no longer 4 shells. 1, 2, 3, 4. It's no longer 4 because it lost that 19th electron. So now it has 3. So it has 3 shells. And what's the Lewis dot structure for potassium ion? It looks like this with 8 dots because there are 8 electrons in the outermost shell of the potassium ion. Okay, I will do a negative ion for you. I'll do sulfur, and then you can do the rest of these. Excuse me, it's not called sulfur, it's called sulfide. Sulfide when it's a negative ion. Well, sulfur on the periodic table is located right here, number 16, which means we know it has 16 protons. That first column is for protons. Second column is for total electrons. Well, sulfur has a charge of -2, which means it must have 2 more negative charges than positive charges. Well, if there's 16 positive charged protons, that must mean that there's 18 negatively charged electrons. We know that also by its location on the periodic table, sulfur gains 2 electrons to have the same number of electrons as argon, the closest noble gas. Okay, number of valence electrons in sulfide would be a total of 8. A total of 8, just like potassium ion. Number of shells is a total of 1, 2, 3. 3 shells because sulfide is on the 3rd row. So the Lewis dot structure, remember showing the symbol, and then it shows the number of valence electrons. In this case, the number of valence electrons is 8. Okay, so that's how you do those problems. I'm going to zoom out so you can look at that again, and then I'm going to start asking all the questions. Okay, there they are. Good luck on your review, everybody. You did it.